Okay, dear students, we are in Limits and Derivatives chapter. Okay, NCERT class 11. This is 13th chapter. We have already started 13.1 exercise in the last class and we have finished 15 questions. Okay, let us try to solve another 10 questions in this class from 16 to 25. Okay, see what they have written. See, continuously until 22 or 23. Evaluate the limits of the following only. If heading changes, I am going to change the heading. Okay. Limit extends to 0. Cos x by pi minus x. This is the 16th question. Okay. See, this is simple question only. If you substitute, answer directly will come. There is no 0 by 0 case. If 0 by 0 case only, then we have to be little bit careful. Okay. See, I am substituting. What will happen? Okay. Cos 0 by pi minus 0. Cos 0 is 1, pi minus 0 is pi, 1 by pi. That is the answer for this question, that's all. Okay. Let us go for 17th question. See, this 17th question, limit extends to 0, cos 2x minus 1 by cos x minus 1. Okay, how to do it? If you do in normal case like, normal position like, you see what will happen. Cos 2 into 0, 0, cos 0 is 1, minus 1, divided by cos 0 directly 1, minus 1, that is equal to 0 by 0. This is going to become 0 by 0 case like, okay. 0 by 0 case we have to avoid and we have to take it into some other case. See, this is case 3. We have to make it case 1. Okay, case 1 normally we are making. We are not making case 2 also. 1 by 0 or something by 0 also we are not making. Limit does not exist like. Let us try to make it as case 1 if possible. If not, at least we can make it case 2. Okay. See, how to convert this? How to make this? Any idea is there? See, if you see like this, it may be cos x minus 1 or cos 2x minus 1. But you have to change it 1 minus cos x or 1 minus cos 2x. For that, a direct formula is there. If you make that, automatically minus has to be taken common. Let us take minus common. You see what I am doing. That is equal to minus of 1 minus cos 2x I am taking. Divided by denominator also minus of 1 minus cos x I am taking. Is it okay? Okay, you see, if I send minus inside, cos 2x minus 1. Cos x minus 1. Okay. Now you can cancel these two minus outside. Okay, minus. That means minus 1 like you can think. Okay, now 1 minus cos 2x formula you are having. Minus has come, 2x has come. You see, 2 sine square x. This is 2 sine square x. Okay, but this is 2 sine square x by 2. Why? Because see here x is there, x by 2. 2x is there, x. Minus is there, sine square. If plus is there, cos square. These two will come. Okay. This has come by the formula cos 2a is equal to 2 cos square a minus 1. With this formula, this has come. Okay. Plus has come like this. Why? Because this is plus. Minus also you can write. So sin square a minus cos square a. Cos square a minus sin square a. Cos 2a is equal to. Okay. Cos square a minus sin square a. With that formula, sin will come. Okay. Now you can cancel out these 2 and all. See, these two I am cancelling out. Whenever off angle comes, means first you can take a square outside. Both are having square. Okay. See, I am writing what I am writing. That is equal to, see, sin x by 2 whole square I am writing. See, I have forgotten to put limit. Okay, we will put last. Okay, but you have to keep limit extends to 0, limit extends to 0, limit extends to 0. Okay. Or else you have to write fx by gx or something like. Function you have taken, separately you have made, finally you have applied limit like. Okay, that also you can do. Okay, now is it okay? Okay, I have cancelled out 2 sin x by 2 whole square. If you send square inside, sin square x by sin square x by 2. Okay. Now what is the advantage? You see, when half angle is there, this also you have to make in half angle. Sin 2a is 2 sin a cos a. Sin a is 2 sin a by 2 cos a by 2. Okay. That formula you apply. See what I have applied. 2 sin x by 2 cos x by 2 divided by sin x by 2 whole square, limit x tends to 0. Okay, limit x tends to 0. Okay, you see, sin x by 2 you cancel out. That is equal to limit x tends to 0, 2 cos x by 2 whole square. Now I feel directly you can apply this limit now. Why? Because now 0 doesn't come here. You need not expand it further. Okay, now directly you can apply. That is equal to, you see, if you 0 apply, automatically cos 0 1 2 into 1 2 into 1 whole square, that is equal to 4. Is it okay? You see, here itself you can apply the limit. You need not square. If you square also, 4 cos square x by 2 will come. 4 into 1 4 only. Anyway, it is okay now. Okay, answer is 4. Note it down. We go for 18th question. Okay, see, 18th question. Limit x tends to 0, ax plus x cos x by b sin x. Okay, directly if you apply limit, what will happen? 0 by 0 will happen. You see, a into 0 is 0 plus, see, cos 0 is 1, but into x into 0, 0 by sin 0, 0 into b, 0. That is equal to 0 by 0. 0 by 0 case we have to avoid. Okay. 0 by 0 case we have to avoid. Okay. What to be done? Think logically. Even if you take x also common, but here x is not there. X is in function. You cannot take common. Okay. See, like our formula. X by sin x. Like that. That also you can do. Yes, sir. X by sin x. Okay. You make it. Okay. See how I am making it. Limit x tends to 0. See, x I have taken by sin x into x I have taken common, or else I will write one more step. What is there? Okay. See, denominator b is there. What I do, 1 by b I will take outside directly. Okay, like a scalar. 1 by b is like a scalar. It is multiplication. I can take it out. Okay. Now here also x I have taken. You see, a plus cos x. Is it correct? First you see sin x. First you see, x I have taken a plus cos x. xa plus cos x. Okay. By sin x. Why? Because b I have already taken out. Like this I have made. Okay. Next time I am splitting this one. You see how I am splitting. That is equal to 1 by b will be like that only. Limit x tends to 0. X by sin x is 1 thing. Okay. 1 by b come for all. 1 by b. Okay, for all this. That is why I am splitting like this. You see, x by sin x afterwards into is there. You keep it in your mind. That means into limit x tends to 0. A plus cos x. Is it okay? I am closing this bracket. Okay. Shall I write like this? First you see this and this. Okay, I have forgotten to put limit. Afterwards I will put limit. Okay, but you have to keep limit also. Limit x tends to 0, 1 by b, ax Ax, x I have taken common, x by sin x, okay, into a plus x cos x, a plus x cos x. Now, okay, now see what will happen. If you apply limit, this is going to become 1. Okay, sin x by x is 1, limit extends to 0. Or 1 by sin x also 1 by 1, like 1 by 1 is 1 only. That is why you can take this as 1. But here if you apply limit, cos 0 is becoming 1. 1 plus a it is going to become. That you have to keep in your mind. Okay, it is not going to become 0. Now you can proceed. Okay, what I am doing, you see, 1 by b, and now I am applying directly limit. Applying limit, okay, 1 by b into, you see, this has become 1 into, this has become a plus 1. Is it okay? First you see, 1 by b is okay, but see, this has become 1 into a plus 1. This has become a plus 1. Okay, why? Because see, limit a you have to take separate only. A is 1 only. 1 plus, again limit extends to 0 is 1. A plus 1. Okay. Now you send b also inside. See, 1 into a plus 1 is a plus 1 only. 1 plus a you can write. 1 plus a by b. Is it okay? First you see. Okay. 1 plus a by b is your final answer. Let us go for 19th question. Okay. See, 19th question. Limit extends to 0, x secant x they have given. Okay. See, normally x, if you apply whatever may be this value, normally if x is 0, 0 has to become. But this should not be 1 by 0. 1 by 0 means again you don't know what is going to happen. Why? Because 1 by 0 means 0 by 0 will come. 0 by 0 means again you have to see to change it in case, another case. Let us see. Secant x, how can you write? Why? Because see, directly by table you can take secant 0. What is the null? Or else what we do, secant x we know very well that 1 by cos x. Let us try to make it 1 by cos x. Okay, that is equal to limit x tends to 0, x by cos x. Is it okay? First you see, why I have written x into 1 by cos x, x by cos x, both are same. Why cos x divided by cos x? You see, secant x is equal to 1 by cos x. Okay, now you can apply limit happily. 0 by 1 will come. You see, that is equal to, see, x tends to 0 means 0 divided by cos 0 is 1. That is equal to 1. See, 0 by something you can get denominator should not be 0 like. Okay, 0 by something is 0. Then this is applicable only. That means we can allow this. Okay, we need not go for another case. 0 by 0 comes, then only we have to go. Now 0 has come. We can go. Okay. Let us go for 20th question. Okay. See 20th question. Question number 20. Limit extends to 0, sin ax plus bx by ax plus sin bx, where a plus b all are not equal. Okay. These are not equal. Not equal to 0. Not equal to 0 like they are telling. Okay. See how to proceed this. If normal way, if you go, I think 0 by 0 is going to come. Why? Because see, sin 0, 0, 0, 0 plus 0, 0, 0, 0 plus 0. Okay, that means this is going to come as 0 by 0 case. 0 by 0 is not acceptable. Okay, then we have to think in different way. See how to change this in normal way. Any idea? What we do, let us make sin ax by ax into ax. Ax we will take. Then let us take x common. Both sides if you take x common, x going to get cancelled. When x going to get cancelled, then into multiplication, x will not be there. Then that will be easy for us. Like that we have to think. Okay. See how I am doing. Limit x tends to 0. Okay. See, ax into sin ax by ax. Ax are going to get cancelled, but sin ax by ax is going to give me one a value. Okay, and I can keep this like this parenthesis first term plus bx. I am not doing anything. You understand? You may ask, sir, you have to do all for Need not required. Why? Because see, one term I have made ax by ax. This term ax get cancelled. Sin ax plus bx is going to come. That's all. Okay. Bx. Here also ax I am not doing anything plus, but here I am doing. You see, bx into sin bx by bx. Not here. Here. First of all, you tell me, is it okay? Whatever I have written. ax are going to get cancelled. Sin ax plus bx is the numerator. bx is going to get cancelled. Ax plus sin bx is the denominator. Okay. Now this is okay. But what is advantage? Advantage is, you see, both are in multiplication. X. Take x common and cancel out each other. Okay. See what I am doing. Limit extends to 0. X I am taking common from numerator. Sin ax by ax plus bx divided by, here also I am taking common x. Sorry, bx will not be there, b only will be there. Okay. A will be there here. I will write here. See what will happen. That is equal to limit x tends to 0. X will be common and x goes means a sin ax by ax plus b. Why? Because x gone outside. Divided by, here also x will go outside. A will be there, okay, plus b, okay, x gone outside, sin bx by bx. Okay, this is the answer. Sorry, not answer. This is the next step. Okay, you see, what is advantage? You can cancel out x. Then there is no 0. Okay, if you send a limit inside, you see, a is constant, a into 1 plus b is constant, b. That means here directly I am writing what I am writing. You see, a plus b by, here also limit extends to 0, a is a plus sin bx by bx is 1, 1 into b is b. You understand now? Directly you can write it. You did not again send limit and all. Directly you can write it. Okay. Like this you have to tackle this question. Let us go for 21st question. Okay, see 21st question. Limit extends to 0, cosecant x minus cot x. Cosecant x minus cot x you have to see. Okay. See, normally if you send x inside, what will it become? 1 by sin x. 1 by 0. 1 by 0 means infinity case, and separate infinity will become. You see here also cos x by sin x. 1 by 0. 1 by 0, 1 by 0. 1, 0 if you take common. 1 minus 1, 0 by 0 only it is going to become. Okay. But 0 by 0 you should avoid. Okay. How it is going to become? You see, this is equal to cosecant x I can take 1 by sin x minus cos x by sin x. Okay. 1 by sin x is equal to 1 by 0. If you apply 0, cos x by 1 by 0, that is equal to 1 minus 1 by 0, that is equal to 0 by 0. Is it okay? First you see analogy. Because the denominator 0 is common, like you can take 1 minus 1 by 0, 0 by 0, 0 by 0 you should not get. Okay. See here only logic is there. You see both are sign common, then you take 1 minus x, like. Then you will get some idea. Okay. See what I am doing now. Limit x tends to 0, 1 by sin x minus cos x by sin x. Already I have written, same again I have repeated. Okay. Here limit I have not written. Okay. 1 by sin x, see cosecant x is 1 by sin x, cot x is cos x by sin x. Tan x means sin x by cos x. Okay, now sin x you can take denominator common. If you take sin x denominator common, limit extends to 0, 1 minus cos x by sin x. Okay, what is advantage? 1 minus sin x you can convert into 2 sin square x by 2. Accordingly, denominator also you have to convert x by 2. X by 2 form. Okay, let me do. See what I am writing. F is equal to limit extends to 0. 1 minus cos x, what I am writing? 2 sin square x by 2. Okay. 1 minus cos x, 1 plus cos x, 1 minus cos 2x, 1 plus cos 2x comes means automatically you have to convert into 2 sin square x by 2 or 2 sin square x or 2 cos square x by 2 or 2 cos square x like. Okay. Now sin will be there here. Sin also, see when numerator is in half angle, denominator also you have to make it half angle. Sin 2a, 2 sin a cos a. Sin a, 2 sin a by 2 cos a by 2. Write down. 2 sin a by 2 cos a by 2. That's all. See, 2 going to get cancelled. 1 sin going to get cancelled. Then sin by cos, what you are going to write? Limit extends to 0. Sin by cos tan x by 2. Is it okay? Sin, one sin will be there, cos will be there, x by 2, x by 2. Sin x by 2 by cos x by 2, tan x by 2. Directly you can apply 0. See, 0 by 0 should not come. Okay, 0 by 0 you have avoided, you have taken it into 0, that's all. Okay, simple 0. 0 is the limit, like you can tell. Why? Because 0 if you apply automatically, tan 0 is going to become, tan 0 is 0. Simple 0 comes means that is correct answer. But like this should not come, 0 by 0. Okay. Let us go for 22nd question. Okay. See here. Limit extends to pi by 2. Tan 2x by x minus pi by 2 question is there. Okay. See, if you do in normal case, pi by 2 is pi by 2. If you send pi by 2, substitute x. Apply limit like as you can tell. If you apply this limit, pi by 2 minus pi by 2, denominator is 0. Even here also you see, pi by 2 into 2, pi. Tan pi is what? 0 only. Why? Because see, tan 0 is 0, 90 is infinity, we can say undefined, and again 0, again infinity, undefined, again 0. Like that circle will there. Sin 0, 1, 0, minus 1. Cos 0, 1, 0, minus 1, 0. Cos, okay. See, sin by cos means sin is here 1 and cos is 0. That is why infinity. But here both are 0 by 1, 0 by minus 1. That is why, what we can say? 0 is there, tan. 0 by 0 will come. Directly I will write like this, you see here. That is equal to 0 by 0. If you apply pi by 2, 0 by 0 is going to come. Okay. See how to convert this from case 3 to case 1. Case 1 or case 2, whatever it may be. Case 2 or case 1. How to convert this? You see, some term like thing comes means you take this as y and see, test. I am asking you to test. If succeeds, then it is okay. Okay. See what I am doing. Let x minus pi by 2 is equal to y. Let x minus pi by 2 is equal to y. Y I have taken. Okay. See, limit also going to take. When x tends to pi by 2, comma, y tends to 0. Is it okay? Why? Because x tends to pi by 2, y is equal to x minus pi by 2. Pi by 2 minus pi by 2, 0. Okay, that is one thing. Another thing, x also you have to write it. Y is equal to x minus pi by 2 means x is equal to y minus pi by y plus pi by 2. X is equal to y plus pi by 2. This also you have to write. Okay. See this line, all 4, 1, 2, 3. 3 or 4. Okay, 1, 2, 3, 4. These 3, 4 you have to write. Then you have to go for substitute and the substitute of this one. Okay. Let us make it as limit y tends to 0. Okay, I am writing in limit y tends to 0 from y tends to 0 tan 2 into x is what? Y plus pi by 2. I will write pi by 2 plus y. Pi by 2 plus 5. When plus is there, anyway I can write, okay? Divided by x minus pi by 2 is y. Y. Okay. See, why I have written like this? See, I want to make it as a sin x tends to 0 tan x by x form. If that comes automatical 1, I can write. Okay, I can avoid 0 or something, 0 by 0 or something like. Okay. Okay. Now, I am sending a pi 2 inside. Limit y tends to 0. If I send a 2 inside, tan 180 plus 2y divided by y. Is it okay? First you see. Why? Because 2 if you send inside 2, 2 going to get cancelled, pi will be there. But 2 if you send inside, 2y will become. Okay, one thing. See here, tan 180 plus theta, how much? You take this as tan 180 plus theta. See, 180 degrees horizontal angle. Horizontal angle means same will come. Tan means tan. If vertical angle means or 90 or 270 are there means tan is going to become cot. But 180 is there, same tan only will become. Okay, tan theta only will become. Okay. But what about symbol plus or minus? You see 180 plus theta 0, 90, 180. 180 plus theta here tan only. Tan and cot. All silver T cups T tan. Okay, that is why this is plus. That means we can write tan 180 plus theta. Here theta is 2y is equal to plus tan theta. Plus tan theta means tan 2y. That we can write. Okay. See, I am writing. Okay. That is equal to limit y tends to 0 tan 2y by y. This I want to write. Is it okay? First you see. Definitely okay. Tan 180 plus theta, tan theta. Tan theta divided by y already there. Okay. Now finally this has become this equation or expression. See now also if directly you can cannot solve this. Why? Because see tan x by x limit extends to 0. Tan x by x only y 1. But here tan x is there, but here x by 2 like is there. Now what you have to do? You have to convert this. How to convert? You see what I am doing. You multiply with 2. That is equal to limit y tends to 0. Okay. 2 tan 2y by 2y. Is it okay? 2 going to get cancelled. Then tan 2y by y will be there. Tan 2y by y will be there. What is the advantage? 2 I can take common constant like scalar. But tan 2y by 2y 1 I can write. Okay. This is equal to 2 limit y tends to 0. 2 I have taken out. Tan 2y by 2y. Now you can write this answer. That is equal to 2 into 1. That is equal to 2. Okay. Like this you have to solve this question. Let us go for 23rd question. Okay. See 23rd question. This is a what we can say typical question. Until now this question we have not done. Inequalities have come. When inequalities comes less than or greater than equal to 0 or greater than 0 or something like, then carefully you have to apply the limits or else you are going to do mistake. Here what you have learned, left hand limit, right hand limit are going to come into picture. Okay, here direct limit is not there. Left hand limit, right hand limit are going to take. Left hand limit equal to right hand limit comes means then limit exists and that limit you are going to write. If left hand limit not equal to right hand limit, then limit does not exist like you can write and close. Okay. See, limit does not exist at where they have asked there. Normally that one. See, limit where they asked, there only we have to tell. Limit does not exist at 0. See, somewhere, some other area it may exist. But if they ask that, there we have to tell. But here they have asked limit at x tends to 0, limit at x tends to 1. But both separate we have to do. First we will do at x tends to 0. Left hand limit, right hand limit. If it is there, okay, we will write limit. Again we will go for limit x tends to 1. Left hand limit, right hand limit. Limit both are there, equal, then is there. Both are different, then limit does not exist at 1. Okay, it may exist at 0, it may exist at 1, but it may not exist at different. Okay, like that we have to write. Let us see this example. If we do automatically, we can get the concept idea. Okay, first I am taking limit x tends to 0. Okay, see, when I am taking, okay, you see, limit x tends to 0 implies what I am doing, left hand limit I am taking, right hand limit I am taking. Okay, first of all I am taking left hand limit. Left hand limit. Okay, left hand limit what? How to write? Limit x tends to 0 minus f of x. Is it okay first? You see, left hand limit is 0, any 1, 0 is 0 minus, 1 is 1 minus, 2 is 2 minus. Left hand limit is left side minus, right hand limit is 0 plus. Like that we will write. Okay. Now carefully if you observe, 0 minus is less than 0, slightly less than 0. Less than 0 means, you see what is there here, this is greater than 0, you should not take this. Less than 0 means this you have to take. If x is less than 0, then you have to take this function, 2x plus 3. Okay. Okay, see what I am doing. That is equal to limit x tends to 0 minus 2x plus 3. Okay, 2x plus 3 you have to take. Taken. But see, what to be done? This 0 only how to send. This 0 only how to send. Slightly less than 0, like you can think. 0 only how to send. Or almost 0 it is going to become. Okay. What will happen? 0 plus 3 it is going to become 3. Is it okay? First you see. Okay. Here there is no special case. If special case is there means that is different thing. Modulus x by x comes means automatically you can take it as something. Okay. But 2 into, see, normally speaking, less than 0 means minus it will be. You think logically. This is minus infinity, plus infinity, here 0. Slightly less than 0 means here minus side, minus x will come. Slightly greater than 0 means plus x will come. See, thus a slight value we don't know, we can take this as x, minus x. But that minus x, if you multiply with 2, small amount, it is far less. Okay, 2 times a small amount means still small amount. If you add 3 means normally 3 only will come. This you can take small amount as 0. Finally, approximately 3 will come. I don't say exactly 3, approximately 3 will come. Okay, like this we will analyze. Let us go for right hand limit. See, these limits you have to understand carefully. This is tricky. When what we can say, inequalities comes. Okay, right hand limit also I am writing, you see, right hand limit. Okay, limit x tends to 0 plus f of x. Right hand limit means 0 plus, left hand limit means 0 minus. Okay, see, 0 plus what I have to write? First of all, let me write x tends to 0 plus. Okay, now you see, equal to 0 also we should not take. Greater than 0 only how to take. Why? Because 0 plus is there. Greater than 0, this 3x plus 3 how to take. 3x plus 3, that is equal to. Here also same case, slightly less than 0 if you give positive value only. Even though it is a positive value, but small amount of value. If you multiply 3 times, small amount of value only it is going to come. It is not going to make any difference if you add with a 3. Finally, this is going to become 3 only. 0 plus 3. Is it correct? First you analyze. See here, very small amount of value multiplied by 3 means, see, one value small is there. Small means like fraction. If you multiply with this, small fraction is going to become big, what we can say, very small fraction. Okay. If you add with a bigger number, 3 is bigger number when compared with this small amount. Then 3 only you can take approximately. Now you say both are equal or not? Left hand limit, right hand limit, 3, 3. Both are approximately equal. Okay. Then you can write like this. You see, left hand limit is equal to right hand limit. Therefore, limit exists at 0 and the limit is 3. Like that you can write and close 50% of this question. Left hand limit fx is equal to right hand limit. Therefore equal to, why? Because 3, 3 equal. Therefore limit exists at 0 and limit is 3. Okay, 3. Let us go for limit 1. Okay, let us go. Okay. Again same process we will do for limit extends to 1 also. Same process. What I am writing, you see, observe carefully. Limit extends to 1 implies left hand limit I am taking first. Left hand limit is equal to limit extends to 1 minus f of x. Okay. This is equal to limit into x2 minus f of x. How to write this? You see, I am writing limit extends to 1 minus. Now you take f of x. See, here equal to 0 or less than 0 only, this you have to consider. If more than 0 means this only you have to consider. That means for 1 minus or 1 plus, you have to take only 3x plus 3 only. That means this limit is going to be existed like already we know. Why? Because see, 0 only they have given inequality, but for 1 they have not given any inequality. That means at 1 there is no inequality, directly you can take it. That means see, for 1 minus also greater than 0 only. 1 minus 1 plus we have to take slightly, this side, but greater than 0 only. Greater than 0 means only this you have to take. Okay? Okay, see, 3x plus 3. That is equal to, okay. See, automatically slightly less than 1 also, like 1 only, 3 plus 3. Is it okay? Value? Okay, 3 plus 3. 6 will come. Let us take right hand limit. Right hand limit is equal to, okay, see, right hand limit extends to 1 plus f of x. First you write f of x, then we will see. As I said, 1 plus or 1 minus, both 3x plus 3 only. Write down. Limit x 1 plus 3x plus 3. Okay. You tell me what will come? 3 plus 3 only. Okay. 3 plus 3 only. Then both are become equal. Then limit is existing like. See, you can tell, sir, both questions are answers come like this only. No, next 24th question you see, the answer is not going to come like this. Then you can understand the concept. Okay. Okay, write down now. What you have to write? Limit extends to 1 minus f of x is equal to limit extends to 1 plus f of x. Therefore, limit exists at 1. Limit exists at 1 and the limit is 6. You understand now? Like this you have to write and close. Let us go for 24th question. Then you can understand the concept. Okay. See, 24th question. Find limit extends to 1 f of x where f of x is x square minus 1 when x is less than or equal to 1 minus x square minus 1 when x is greater than 1. See, here also inequalities are there. Then little bit carefully how to do this question, or else you are going to get a wrong answer. Directly you cannot get. See, limit extends to 1. Where they are asking, there only inequality is there. Earlier question, they have asked at 0 and 1, but inequality was there at 0 only. The 0 only you are very well carefully how to write. But for at what we can say, 1, that much carefulness is not required in last class, last question. But here, 1 only inequality is there, carefulness is required. Okay. See, I am writing how. First we have to take left hand limit. Left hand limit, comma, limit x tends to 1 minus. Why? Because 1 is asking, I am taking 1 minus f of x. That is equal to, okay. See, limit x tends to 1 f of x minus 1. What will become? Limit x tends to 1 minus. Now fx, what would be written? You see. See, 1 minus means less than 1. Slightly less than 1. Slightly less than 1. Shall I take this one? X square minus 1. Okay? Okay. X square minus 1. Okay. Now you substitute. Now you substitute 1. See, slightly less than 1 means, see, in positive number only, that is, not a negative number. Okay. That is equal to 1 square minus 1. Is it approximately 0? Not exactly 0, but approximately 0. Why? Because slightly less than 1 square, like 1 only will come. Okay? You can take approximately 1 like 1 square minus 1, 0. Okay? This is left hand limit. Let us go for right hand limit. Let us go. Right hand limit, comma, limit x tends to 1 plus f of x is equal to, okay. Here 1 minus, here 1 plus. This is left hand, this is right hand. Okay, see, slightly greater than 1 means this function you have to take. Minus x square minus 1. Is it okay? Definitely okay. Okay. Now you substitute. Yeah, now you substitute. Minus of 1 square minus 1. Is it okay? See, here minus x whole square not there. Minus of x square, minus of x square. That means first you have to square x, then you put minus outside. Okay. I have made 1 square, 1 minus of 1, then minus 1. That is equal to minus 2. Now you tell me 0 and minus 2 both are equal? Not equal. Then what you have to write? See what I am writing now. Limit x tends to 1 minus f of x is not equal to limit x tends to 1 plus f of x. Therefore, limit does not exist at 1. See, limit may exist at different value, but at 1 it is not existing. Your question is at 1 you have to check. At 1 you have checked, it is not existing. Both are different. You see 0 and minus 2 are coming. That is why limit does not exist at 1, like you write and close. Now you understand carefully. In last question, all are okay. But in this question, both are not okay. That is the specialty of these limits. Okay. Let us move on to 25th question. That will be last question for this class. Okay. Okay, see carefully this question, carefully how to tackle. Evaluate limit x tends to 0 f of x, where f of x is modulus x by x when x is not equal to 0. 0 when x is equal to 0. See, 0 when x is equal to 0, okay. But when x is not equal to 0 means it may be less than x or less than 0 or more than 0. Greater than 0 comes also, you have to take this formula, this what you can say equation. expression, and less than 0 comes also, this expression you have to add. That means minus 0. See, whatever it may be. See, here rather than 0, you have to take. And he asked us to find at 0. You see very carefully. Okay. Okay. What do we do here? Here we will take less than 0 value as minus x, greater than 0 as plus x. Okay. You see what I am writing. Carefully observe this question, or else you are unable to do this question. Here 0 is there. Less than 0 is minus x you take. Greater than 0 is plus x you take. Why? Because slightly you have to take greater or less. So you cannot do anything. Okay. Okay. Let us do first what we are going to do. Left hand limit we have to find. Write down. See, limit extends to 0. When inequality has come, this is like inequality only. When inequality comes, then you have to take this left hand and right hand limit. Write down. Left hand limit, comma, limit x tends to 0 minus f of x is equal to. Okay. See, for left hand limit, right hand limit, same this equation only applicable. Why? Because not equal to 0. Not equal to 0. Less than 0 or greater than 0, both are going to become not equal to 0 only. Na? Okay. Now see what you have to write here. Limit x tends to 0 minus modulus x by x you have to write. Modulus x by x. Okay. Now you tell me at less than 0 what is going to become minus x. You write down. That is equal to minus x modulus by minus x. Why? Because x is minus x here. They have given x. Okay. Let us take y or a. Why? Because if I write x, you are going to get confused. Let me take minus a or plus a. That means x is a. Minus a or plus a I have taken. Slightly less than 0, minus a, slightly greater than 0, plus a. Why? Because 0 is the midpoint between negative number and positive number. Less than 0 means negative number, greater than 0 means positive number. Okay? Negative, positive. Okay. See, minus a plus a I am taking. You see, less than 0 means both are. So less than 0 means minus a I have to take. Minus a I have taken, but I have put modulus divided by minus a. That is equal to minus a after modulus is going to become plus a. This is minus a like that only. Then minus 1 will come. Is it okay? First you see. Why? Because again if I take x, already they have given x, you are going to get confused. I have to write minus x, but you may ask, sir, if denominator plus x is there, why you have written minus x like? X is equal to a like you take. Okay, this diagram also you write in your examination side. This is left hand limit minus 1 has come. Let us see right hand limit what will come. Sorry. Right hand limit also I am writing, you see. Right hand limit, comma, limit x tends to 0 plus f of x is equal to. Left hand limit 0 minus, right hand limit 0 plus. Same f of x, f of x. You see, at 0, this one. But not at 0. That means less than 0 or greater than 0. Both this equation only you have to take expression. Take it. Minus x, sorry, modulus x by x. That is equal to. Okay, now come here. See, slightly greater than 0. If you take this is going to become plus x. Plus a. Write down now. Plus a modulus plus a, that is equal to. See, modulus also same, plus a only will come. Here also plus a only will come. This is 1. Now you tell me minus 1 and 1 both are same. Not equal. Then what you have to write? Now I am rubbing this. Limit does not exist at 0 I am writing. Why? Because see, at 0 value they have given. Minus 1, 1, 0. 3 values are going to come. See, so as per sandwich theorem, extreme ends minus plus both are equal, then in between normal you need not see. 0 plus 0, sir, 0 minus 0 plus both are equal. In between 0 will be equal only. But 0 minus 0 plus both are not equal, then you can see 0 also. Then 0 is also different here. All are different. Okay? You write down like this. 0 is what will come? 0 is 0 only. That also you can write. Limit x tends to 0, f of x is equal to limit x tends to 0, 0. That is equal to 0. Okay. See why we need to take in last two questions we have not taken. Only minus plus we have taken. With minus plus only, if both are equal, okay. Both are not equal, then not equal. That's all. Okay? Okay, write down. Now, limit x tends to 0 minus f of x is not equal to limit x tends to 0 plus. Therefore, limit does not exist at 0. Okay? Why? Because minus 1 plus 1 has come. That is why not exist. Like you write and close this 25th. See, we have completed 25 questions. Still 7 questions are there. 32 questions are there in this exercise. Okay? We will try to solve remaining 7 questions in the next class. Okay? Thank you very much.